Let us talk about standard normal distribution today. We talked about normal distribution in the earlier recording. Now let us talk about the standard one. So standard normal distribution, one characteristic is that it has a mean of 0 and the standard deviation of 1. And if you remember, we were talking about one kind of an example that day, where we said that we have a data which has a mean of 29, and the standard deviation of 6. So you have one standard deviation here, it's 35, minus one standard deviation here, which is 23, and so on. And if you remember, we also talked about an empirical rule. What was an empirical rule? Empirical rule was that for a normal distribution, 68% of the data is going to lie between plus 1 standard deviation and minus 1 standard deviation from the mean. Then we said this was 68%. I'm repeating this stuff because this is important for you. Then 95% of the data is going to lie between 2 and minus 2 standard deviations of the mean. %95 of the data is going to lie between 2 and standard 2 deviation from the mean. And around 99.7% of the data is going to lie in 3 and minus 3 standard deviations from the mean. That is there. Okay. Guys, you remember now the example which we took? It has a BMI.
I'm sorry. I'm afraid I can't do that.
So if you remember, the example which we took was that BMI has, so it was a population of the people 60 years and above, and it has a mean of 60. So instead of X bar, I should be rather writing mu, and the standard deviation of 6. So we are saying that the standard normal variate is this, or Z score is going to be this. Now for BMI equals to 30. So your Z score is going to be 30 minus 29 upon 6. That is 1 upon 6. That is 0.1667. So if I'm going to draw this graph for the standard normal variate, so it is going to be what? It is going to be 0, plus 1, 2, 3, minus 1, minus 2, minus 3. So it has a mean of 0, and the plus and minus 1 standard deviation, plus minus 2 standard deviation, plus minus 3 standard deviations like this. And the example which we took, it is going to lie somewhere here. So it is just this here, somewhere here. This is what your 0.1667 is. This is what 0.1667 is. So if I want to find out that what is the probability that a person who is selected at random will have a BMI of less than 30, right? So if I want to compute Px less than 30, it is equivalent of computing Pz less than 0.1667. Or you want to make your life simple, you can just write this as z less than 0.17 like this. So what you can do is that you can look at the normal table like this. 0.17, 0.171 and 7 out here, somewhere here. So 0.1 and 7 here, 5625. 5675, sorry. So from the normal table, we found out z less than 0.17 and 0.5675. So the probability that a random male who is selected will have a BMI of less than 30 is 56%. That is the meaning of this. So thus, the probability that a male aged 60 has a BMI of less than 30 is approximately 56%. Is approximately 56%. You with me? Let us look at one or two more examples. So we have this question. Suppose the scores are normally distributed with mean of 527 and the standard deviation of 112. So it has a mean of 527 and a standard deviation of 112. What is the probability of an individual scoring above 500 on the test? And how high must an individual score to be in the highest, 5%? So this is a normal distribution. Yes. Mean is 527. So I'll calculate what the Z score is. X minus mu upon standard deviation. So that is your 500 minus mu 527 upon standard deviation. That comes out to be minus 0.24 approximately. So 500 is lying here somewhere. 500 is lying here somewhere. So I need to find out now, in case of the standard normal variate, how will it look like? This is going to be 0. And the Z score of 500 is what? Minus 0.24. Minus 0.24. Right? So what will I be doing? I'll be finding out this 0.24 from the Z table. So let's have a look at that. 0.2 I'll take from here, and this 0.4 I'll take from here. So it is coming out to be 0.5948 here, this thing. So I need to find out this guy. So what is the probability of an individual scoring 500? That is above minus 0.24. So I have found out from there, this comes out to be 0.5948. No? 0.5948. Let me just show you once more. Yeah, 0.24, 0.2, and from here you'll pick up 0.04. Fair enough. Okay, the next part says, how high must an individual score be to be in the highest 5%? To be in the highest 5%. So you have the normal distribution like this. This guy is 527, right? I want it to be above this, right? This guy here, somewhere above 5%, in the top 5% types. So if I just put this in perspective, so the standard normal variate here is going to be 0. I want this thing. So it is going to be, this entire area is going to be 0.95. No, I want here, this is what 0.05 is. So this entire area is 0.95. So 0.95 from the Z table will look like what? 0.95, 0.95, 0.95 I need to find out. 0.95 somewhere here, no? Yeah, 1.6, and from here it is 5. So here, so I'll take a 1.6 here, and this is 0.5. So in terms of the Z distribution, so this comes out to be 1.645. 1.645 here. So what will be the value of X then? I had the value for Z, which is 1.645. I need to find out the equivalent value of X. Mu is given to me, which is 527. And standard deviation is also given to me, which is 112. So once I calculate this, I have X coming out to be 711.24. So if the person wants to be in the top 5% in the test, he has to score above. So equivalent X score is 711.24, right? So in this recording, we understood what is the standard normal variate, how to check it from the table, that's its score, and we did one example based on this, right? Thank you, Beta.